All right, so we're in the home stretch. So now we've got, say, a complex market demand function, and we would like to be able to calculate the price elasticity of demand for it. And so, how do we calculate a PED for this complex market demand function at a price of 50? Well, fortunately, I have both the demand and inverse demand already done for me. So that's good. So I didn't have to do the extra work of doing the inverse. So I just have to remember the formula here. And remember, in these elasticity things, the thing that comes after the of is going to be in the kind of numerator in the differential equation. So it'll be in this case, the partial Q, the dQ there, if you like that. And the thing that comes in front of the elasticity, that goes in the denominator. So that's the dP. So price elasticity of demand goes up top and price goes below because P comes first and D comes last. They're sort of saying, how much does the numerator change when you change the denominator? So that's how you read that encoding. And then we have to scale it by P over Q because basically we're taking this partial Q over Q, that gives us our relative change in quantity, and we're dividing that by the partial P over P, and that gives us our relative change in price. All right, so we need to calculate this where price is equal to 50. So if I look, price is equal to 50 down here somewhere, so that means I'm going to be writing some point over here. So that's what we've got right there. So fortunately, I've got my demand here, so I can actually calculate what that point is. So for 50, I'm in this top range here, so I could do 200 minus 2.5 times 50, and that would tell me that 75 is the quantity demanded. So I've got my price, 50, and quantity demanded, 75. So if that's the P and the Q, so all I need to know now is the slope of this thing, which I know on this curve, the slope is minus 2.5. So that's what we've got right there. I just took the derivative of this thing with respect to P, and I got a simple minus 2.5 out. If this was a quadratic or something like that, if it was like P squared, then you'd have to remember some of your calculus rules about how to take these derivatives. I'm going to try to not give you anything too crazy when I do these things. It'll be like polynomials, like the derivative of P squared is 2P, that sort of thing. The derivative of P cubed is 3P squared. Now, when it's not linear like this, like if I did have a P squared here, like if this was minus 2.5 P squared, the derivative of this thing would have given me a minus 5P because of the 2P squared. The derivative of that is 2P, and then the 2P would be multiplied by the 2.5 to give me 5. Now notice there's a P that shows up in the derivative, so that would mean that I then have to plug in the price, which is 50. So right now it's just a static minus 2.5, but if it was minus 5P, I have to do minus 5 times 50, and that would give me a minus 250 for this slope. So just things to keep in mind that maybe you'll see in the Canvas exercise that'll follow this. Okay, so now, so how do we put that all together? Well, we just take the PED formula. We've got the slope here, multiplied by the price, 50, divided by the quantity, 75. If I do minus 2.5 times 50 over 75, I get like 1.6 repeating, so just approximate it as 1.67. That's positive. It's not only positive, but it is greater than 1. So we say that this is elastic. Elastic meaning that if I got a 10% change in price, I will get more than 10% change in quantity around this point. So that's what we mean by elastic. And if you look at it, you can kind of see that because the price is so low, a 10% change in price is not very big, but this slope is kind of shallow. And so already small changes here will get larger changes here, and then the quantity is not very, very large, and so as long as the large changes are kind of large enough, then it's pretty easy to have a greater percentage change in quantity than we had percentage change in price, and that's why it's elastic. All right, so let's try a different variation. So we can say, what is the PED at a quantity of 5? Okay, so a quantity of 5, that's like way down here, which is way up here, right? And so it's much steeper. So how do we do that? Well, I've given you a quantity, which means I go to the inverse demand. I need to look at which range 5 is in. It's in this range, okay? So I plug 5 into this formula. 10 minus 2 times 5 gives me 90. So the price is 90 for a quantity of 5. If I look at the slope, remember the slope is always of the demand function. So that you have to be careful about. Even if you've been plugging things in to the inverse demand function, the slope here is of the demand function, which is this minus 0.5. Now, you might notice that this minus 0.5 slope of the demand function is 1 over the slope of the inverse demand function, and that's not sort of a mistake. But either way, just to be safe, go to the demand function when you take your slopes. And so now we have all the information we need. We have the slope at that point, we have the price at that point, and we have the quantity at that point. So we can calculate the absolute value of the PED. There's our slope, minus 0.5. There's our price, 90. There's a quantity, 5. And look at that. Now it's actually much, much more elastic. It's still elastic, still greater than 1, but it's even more elastic than before. And you might say, well, why is it more elastic? Well, one reason is that the price is so large that that the same unit price is always going to be a small percentage price, and the quantity is so small that even if you get a couple units difference, you're going to have a major percent change in quantity. So that 90 divided by 5, that is enough that it's sort of driving this. It's going to dominate this elasticity, just that by itself, and then that then gets scaled down a little bit by the steep slope here. So even though the slope of the demand curve is steep, because the price is so high and the quantity is so low, the elasticity is high. So it still has a high elasticity. All right, so most of you, I think you may have looked at that and just assumed that since this was steep, when you look at anything that's steep, you think, well, okay, that means I could have a huge fluctuation in price, and I'm only going to small fluctuation in quantity, and that makes you think that it's inelastic. But because elasticity is defined in terms of percent changes, then we really care about exactly what we're normalizing to. And so because it's a high price and a low quantity, it's still elastic even though it's on a steeper slope. All right, so let's go back and give that a shot with an even more interesting market demand function that I've put in the Canvas exercises. So try that out, and then we'll move on to the last part.